Welcome to tonight's video on hyperbolas. Hyperbola is a conic section that basically is distinguished from having two parabolas from a common point in the middle. You could either have them going horizontally like this, or the parabolas could go vertically like this. And they are equidistant from the center. So this distance from the vertice to the center is the A, whether it's vertical or horizontal. And then there is also a focus in each parabola, and that is your distance of C. All right, and the equations to find C is right here. C squared is equal to A squared minus B squared. And the A squared and the B squared are on the bottom of the hyperbola. The way you tell that it's a hyperbola is that you are subtracting. The way you tell if it's horizontal or vertical is by which variable comes first. So since x squared is first, it's x squared minus y squared, then it's going to be horizontal. So we'll first look at when the center is the origin. So right here, the center is 0, 0. So the center is right here. And we know it's horizontal because x squared comes first. So a squared is equal to 4. That means a is equal to 2. So that means you go 2 to the left and 2 to the right, and those are your vertices. To find the foci, remember c squared is equal to a squared plus b squared now. So this is a squared, this is b squared. So c squared equals 20. So c is equal to 2 rad 5. And they are, so the foci would be negative 2 rad 5, comma 0, and positive 2 rad 5, comma 0, because the foci are going to be here. And remember, 2 rad 5, if you type it in your calculator, is like 4.5. So there are your foci. And then to draw hyperbolas, you can draw what are asymptotes, and those are going to be guides for your hyperbola. And to find the equation of the asymptotes, you can do like the equation of a line. You can take the center and the slope. So since we know the center is 0, 0, and then the slope is going to be, in this case, since it's horizontal, it's going to be positive b over a and negative b over a. Because remember, when you do the slope, it's the change in y over the change in x. So to find the slope, in this case, you know b squared is 16. So b is going to be 4. So to find the slope of the asymptote, the line, it's going to be 4 over 2 and negative 4 over 2, which means it's 2 and negative 2. So remember the point slope form of a line, y equals m times x minus x1. So you can go y minus 0 equals 2 times x minus 0. So basically it's just y equals 2x when you distribute. And here, same thing, y minus 0 equals negative 2 times x minus 0. So it's just going to be y equals negative 2x. So those are the equations of the asymptotes for this. Now, you can either start at 0, 0 and go up to over 1 and draw your asymptotes, or another way to do it is to also, from the center, use the b, which is 4, put a point, and negative 4, and then you can draw a box. So when you draw this box, you go out 2, and then down to the 4, and across. So you're drawing the box from the center 2 and 2. So it's going to have 4 that way and then 8 this way. And then your asymptotes are going to start from the center and go through the corners of the box. So if you start at the center and go through the corners of the box, those should be your asymptotes. So they're like dotted lines that form an X through the center. And the importance is that if you start from the vertices here and there, that the asymptotes will be guides. The parabolas will follow the asymptotes through. So it looks like that. Now, the domain, if you notice, it's going to go from negative infinity until the first vertice on the x, which is -2, union, because there's a gap here, and then it's going to go from 2 to infinity, whereas the range is all real numbers. Something to consider, if you notice, your equations were y equals 2x and -2x. So if you go up 2 over 1, up 2 over 1, that still makes sense for that line. And the same thing if you go up 2 over 1 here and up 2 over 1, you get that line. So that's just another way by drawing the box to draw the asymptotes. So now if it's a vertical hyperbola, meaning the y comes first. So notice a squared is 4 and a is 2. B squared is 9, so b is 3. And c squared is equal to 4 plus 9, so c is equal to 13. Or sorry, c squared is 13, so c is the square root of 13. And so to find the vertices, remember the center is 0, 0, because it's just y squared and x squared. So you're going to go up 2 and down 2 now. And those are your vertices. So it's 0, 2, and 0, -2. And then the foci are going to be 0 and positive square root of 13. And 0 and negative square root of 13, because they're going to go up here. And remember, square root of 13 is like 3.5. So it's right there and right there. So those are the foci. And then the asymptotes, to write the equation, and we'll come over here and do it out into space here. Well, remember, the center is 0, 0. And the slope is going to be, now because y is the a and x is the b, so now the slope is going to be a over b and negative a over b. So basically think of whatever's underneath the y has to come first, and then x is what it's over. So in this case, the slope is 2/3 and -2/3. So when you write your equations, y minus 0 equals 2/3 times x minus 0. So it's just y equals 2/3 x. And y equals -2/3 x minus 0. So y equals -2/3 x. So those are the equations for your asymptotes over here. But remember, the best way to draw it would be to use the b term, and remember the b term was 3, so if I put the dots here and here, and if I draw the box, and then draw the asymptotes through the center and the corners of the box. There, and there. So then, when I draw this, I start at the vertices, and now I'm going to go up and follow the asymptotes, and I'm going to go down and follow the asymptotes. So now, when it's a vertical hyperbola, the domain is all real numbers, and the range is negative infinity to the first vertice, which is -2. and from 2 to infinity. That is the range.